All right, let's take a look at question 27 from the 2024 Advanced Maths paper. We're told to find the derivative of x squared times tan of x. This question, incidentally, is a very classic impossible integral question. So they'll give you an integral in the second part that's impossible with the tools you've been given in advanced maths, or difficult, extremely difficult with the tools you've been given. But it's easy if you happen to know that a particular function's derivative looks like the function you're trying to integrate. Because if you start with a function f of x, you differentiate it, you take d dx, this gives you a new function f prime of x. If you take f prime of x and you integrate it dx, this pretty much returns you to the function you started with. Right? It's not necessarily always exactly the function you started with, but it's very similar to the function you started with in most cases. Sometimes you'll have a constant of integration instead of a numeric parameter. So let's do the derivative. So for part A, we've got our y equals x squared times tan of x. U, v, this is product rule. So u is x squared, u prime is 2x. V is tan of x. V prime, now the derivative of tan of x is secant squared. So this is secant squared of x. So we end up with y prime is u prime v, which is 2x tan of x, plus u v prime, which is x squared times secant squared of x. So for the derivative, this is what we're after. Now the question tells us to hence find the integral of this particular function. Well, the thing in this question doesn't quite look like the thing that we have in our question, but it's not dissimilar if we can make some tan substitutions and then factorize. So we have a secant squared here. We only want tans. So for part B, we need to turn this into all tans. We know 1 is sine squared x plus cosine squared x, triangle identity. Secant squared is 1 divided by cosine. So divide everything by cosine squared x. Cosine squared x. Cosine squared x. This term becomes a 1. This term becomes a tan squared x. And the first term becomes secant. So we've got secant squared x is equal to tan squared x plus 1. So we're going to sub this in for the secant squared. So our y prime function is 2x tan x plus x squared times tan squared of x plus 1. Now we can try to factorize this expression, and we want to try and turn it into something squared. So let's rearrange this. We'll expand the bracket x squared tan squared x. So we've got x squared tan squared x plus 2x tan x. And then at the end, we actually have plus x squared. Now we're going to try and factorize this. This particular expression should have an x and a tan of x in it. So we should have x times tan of x. This squared gives us the first term. We need 2x tan of x in there as well. Well, the way we're going to get that is multiplying that by 1. So it's going to be x tan of x plus 1 all squared. However, this x squared here we haven't considered. And this 1, if we square 1, we'll have a 1 in here. So we have to have these at the end, plus x squared minus 1. So this thing in here, this is the thing in the integral, but we're just missing the x squared and the 1. So we know that when you integrated the original, when you took the derivative of the original function, it gave us this. This was the function we ended up with. So if we want to take the integral of this, we just need to remember to deal with this x squared and this 1, right? So what we really want to do is we want to substitute this in. So we've got d dx of x squared tan of x minus x squared plus 1 is equal to bracket x tan of x plus 1 all squared. So really, we just need to take the integral of this. Now, this is a slightly sloppy way of doing this. We're sort of rearranging the expression to try and fit it into the integral, but it is going to work. So we take the integral of this with respect to x. Well, the integral of the first thing is just x squared tan of x. So we find the integral of bracket x tan of x plus 1 all squared dx is equal to x squared tan of x. The integral of minus x squared is minus x cubed on 3. The integral of 1 is plus x, and then we need a constant of integration. So this is the evaluation of the given integral. It would have been very hard to do this if we didn't have the function provided in part A and they didn't tell us to take a derivative. You would have to use something else, some other process like an integration by parts, which doesn't happen in the advanced maths curriculum.